This recording is for Algebra 1, Chapter 3, Lesson 6, Absolute Value Equations and Inequalities. This lesson's not too long, but I don't want to give you a quote just so I can keep your mind focused. So, alright. The absolute value of a number is its distance from 0. Because absolute value represents distance, it must be positive. A variable inside absolute value bars has two possible answers, normally a positive and negative version, but this is not always the case. Sometimes they're both positive, depending on how the problem works. Sometimes they're both negative, but you'll see examples coming up. But normally there's a positive and a negative, but not always. So the plan of attack is to do the problem twice after simplifying, which means getting the absolute value bars by itself. The one big thing that you need to know about is that even though absolute value bars act like grouping symbols, you're not going to distribute with them. Okay, you can't distribute with absolute value bars. You can with parentheses, brackets, and braces, but not absolute value bars. Okay, so here is an example problem. We have the absolute value of t minus 2 equals negative 1. Well, the first thing I'm going to do is I'm going to get t, the absolute value of t by itself. So I'm going to add 2 on both sides, add 2 on both sides, and I'm going to get the absolute value of t is equal to 1. Well, there's two things t can be. T can be equal to 1, or t can equal negative 1. Alright, so those are the two answers. Now, when it's the same number but on opposite sides of the 0, you can go ahead and say t equals plus or minus 1. Okay, so there's one way that you can write it, or you can write it this way. Alright, it's your choice. But this is basically an example of breaking it into two, where you set whatever is inside the absolute value bars equal to a positive version of what's on the other side of the equal sign, or a negative version of what's on the other side of the equal sign. So here's another example. How am I going to get n by itself? Well, I'm going to divide by 3. Divide by 3. The absolute value of n is equal to 5. Alright? Well, I'm going to do this twice. I'm going to do n is equal to 5, or n is equal to negative 5. Because, well, what's the absolute value of 5? 5. What's the absolute value of negative 5? 5. So n equals plus or minus 5. So again, there's two answers here, and in this case, one's positive and one's negative. So let's go ahead and keep going. Alright, so how do I undo this situation? Well, I'm going to plus 2, because I need to take care of lower priority things first. It's going to give me 6 is equal to 3 times the absolute value of w. Divide by 3, divide by 3. 2, w equals 2, or the absolute value of w equals 2, so w can be plus or minus 2. Okay? Now, let me give you a quick example problem, just so I can mention it once, even though I'm going to mention it again. What if I have this? How do I solve for w? Well, I'm going to, so this is 4 equals 3 times the absolute value w plus 6. Well, if I minus 6 on both sides, I'm going to get negative 2 equals 3 times the absolute value of w. I'm going to divide by 3, divide by 3. Negative 2 is over 3 is equal to the absolute value of w. Well, this is a false statement. You cannot do anything with this. The absolute value of w means that the answer needs to be positive. Since this answer is negative, we say that this has no solution. Okay, so you need to pay attention to that. Once you get absolute value equaling a negative, where it's just the absolute value, up here, you probably, unless you did it mentally, you wouldn't be able to know right off the bat. Well, maybe once you got to that step, you would know. But once you get absolute value, a straight absolute value with nothing on the outside, equaling a negative number, you've got a problem, and the problem is that there's no solution. Okay, next up, just some more example problems. What happens if you've got stuff inside the absolute value with the letter and you need to get rid of it? Well, automatically you're going to break it up into the two equations. You're going to have c minus 2 equals 6, or c minus 2 equals negative 6. And then you're just going to solve. So you're going to add 2, c equals 8, or plus 2, c equals negative 4. Okay, so that's your answer. Now, obviously, you can't write c equals plus or minus 4 or c equals plus or minus 8 because that's not true. If you were to plug negative 8 in for c, you're going to have negative 8 minus 2, which is going to give you negative 10, and the absolute value of 10 is not 6. And the same thing with positive 4. If you plug 4 in there, you're going to get 2. The absolute value of 2 is not 6. So there's two answers here, and this is one of the cases where you obviously can't use plus or minus. All right, next problem, you're going to do the exact same thing. You're going to have negative 55 is equal to t plus 2, or 55 is equal to t plus 2. And whenever you're doing this, you're always taking a positive version of the thing that's alone and a negative version. So since this was negative already, I need to take the opposite of that, which would be the positive 5.5. So now if I subtract 2 on both sides, this one's going to give me negative 7.5 equals t, or minus 2, that's what, 3.5 equals t. So those are the two answers that work. Okay, so for this one, we've got 7d is equal to positive 14, or 7d is equal to negative 14. So I'm going to divide by 7, d is equal to 2, or divide by 7, d is equal to negative 2. So here, we're going to get d equals plus or minus 2. So occasionally they'll show up, all right? But, you know, it's more apt to show up for the plus or minus when you're multiplying or dividing as opposed to adding or subtracting. All right. Inequalities, all right? Rules for solving inequalities. Use your brain and think, is this mathematically possible? So if you have the absolute value of a and it is less than b, but b is still greater than 0, then a needs to be between negative b and positive b. If the absolute value of a is greater than b, but b is greater than 0, then the absolute value of, then the answer means that a is going to be less than negative b, and a is going to be greater than b. It's kind of like the compound inequalities, where you'd have an inequality that kind of looks like this. So if this is 0, and this is b, and this is negative b, a is going to be greater than positive b, but less than negative b. Okay? So, and then this one would be an and statement. Okay, well, this is actually more of an or statement, right? It's an or. And or from the compound inequalities from the last lesson. If you're needing help with that, go back and watch the last lesson. That doesn't help, definitely come see me. Okay, you're still going to do the same thing that you did before, where you break it into two problems. The only thing is when you take the opposite of this number by itself, you also need to flip the inequality sign. So it's going to be n is, or excuse me, not the absolute value, n minus 1 is less than 3, or, right. So we're going to have actually more of an and statement than an or statement. So then we're also going to have n minus 1 is greater than negative 3. Okay, so if I plus 1 on both sides, n is less than 4, and plus 1, n is greater than negative 2. So then if I graph it, we're going to have 0, 4, and actually, let's make this a little prettier. Oops. So I'll do the number line up here. So then if we have 0 and 4 and negative 2, n is greater than negative 2, but n is also less than 4. So any of the answers in between negative 2 and 4 is going to work for n in this case. Okay? So let's do one more here. Let's see here. So we're going to have n minus 1 is greater than 3, Well, since this is greater than b, and b is greater than 0, so this is going to be an OR statement. N minus 1 is less than negative 3. Okay? So we're going to add 1, n is greater than 4, or plus 1, n is less than negative 2. And then if I use my number line, it's actually a space. We have 0 and 4 and negative 2. So n is less than negative 2, so it's going to go that way. And if we have n is greater than 4, we're going to go that way, which is definitely an OR statement, whereas this one was an AND statement. Okay? All right. Word problems. These ones are way more complicated than, they look more complicated than they are. You just need to remember that you're basically doing a plus or minus on something, and to show that you're using absolute value. Okay, just like we had before would be like the answer would be plus or minus 1. Well, we're using that plus or minus and then showing it using the absolute value. So the ideal diameter for a piston for one type of car engine is 90.000 millimeters. And this is what we call a precision amount. It has to be exact to that amount of zeros. It can't be 90.1 and still be considered ideal. It has to be measured up to 1,000, tens, hundreds, thousandths, up to 1,000th of a millimeter. Okay, so it's a very precise measurement. All right, the actual diameter can vary from ideal by at most 0.008, so up to 8,000ths of a millimeter, which is very, very specific. All right, find the range of acceptable diameters for the pistons using an inequality. So what we're going to do is we know that we have the diameter of an average piston. Let's say we could go measure any piston we want, and we're going to get the diameter D. Now, if we subtract the ideal, we're going to get how far off it is. How far is this average piston from the ideal amount? And so if we take the absolute value, either plus or minus, this needs to be less than 0.008, or 0.008 millimeters. Okay, so this is any piston. You could walk through the factory and just measure pistons. And so the first piston you measure, it could be 90.0007. Well, if you subtract that, you do 90.0007 minus the ideal, and you're going to get an exponent, a very small exponent. So it's going to be 7 to the negative 4, 7 times 10 to the negative 4th. 7 times 10 to the negative 4th is 1, 2, 3, 4. So that's 0.007. Well, is 0.007 less than or equal to 0.008? Well, yes it is. So the piston that we measured here does work, okay? And then you can measure another piston and see if it works, but if you ever get something where when you subtract the ideal and you get something greater than 0.008, you know that the piston needs to be rejected because it is not close enough to the ideal based on the minimum and maximums, all right? So basically you can say that the piston can be plus or minus 0.008, or 8 from, or no, 0.008. So 0.008 from the ideal. Okay? All right, so another similar question would be the ideal weight for one type of model airplane is 33.86 ounces. The actual weight may vary from the ideal by 0.05 ounces, and we need to find the range of acceptable answers. So we're going to set it up the same way. We could say that we're going to have, we went through and we measured an engine, and we're going to subtract the ideal, and that absolute value, either positive or negative, needs to be less than how much it can be off by. Okay, since it can be off by 0.05 ounces, whenever we subtract, it has to be less than that amount, either plus or minus, because we could have an actual low one. So let's say we have an airplane engine that was 33.6 33.79. Well, if we subtract the ideal, we're going to get a negative number. So that's 33.79 minus 33.86. Oops, 1 second. 0.79 minus 33.86. And we're going to get negative 0.07. Well, the absolute value of that is 0.07, which is not less than that. So the engine that we, false. The engine here is the weight is too small. It's doesn't fit into our range. So that would be a false one, and I'm sure you could come up with examples where they're true. All right, I am done. Thank you for sitting with me. This lesson is a little tricky. Hope you got it, or if not, watch it a second time so you can get it. All right, bye guys.